Hi friends, welcome to our channel. Okay, today we are going to continue our topic atomic structure class 11 chemistry. This is part 7. Okay. So before class we discussed up to isotones. Now we are going to continue. The next topic is isodiaphers. Okay. So isodiaphers, the atoms of different elements having same isotopic number. The atoms of different elements having same isotopic number is called isodiaphers. So what is this isotopic number? Okay, there is one formula to calculate the isotopic number. So isotopic number I is equal to A minus 2Z. Okay, isotopic number I equal to atomic mass minus 2 into atomic number. Okay, now let us take two elements having same isotopic number. When we take fluorine, atomic number is 9, atomic mass is 19. Isotopic number is 19 minus 2 into 9, 18, that is 1. Isotopic number of fluorine is 1. When we take sodium, having atomic number 11, atomic mass 23, the isotopic number is 23 minus 11 into 2, which is 22, 1. So fluorine and sodium having same isotopic number, so they are called isodiaphers. Okay, this is about isodiaphers. Now let us discuss isosters. Okay, now let us discuss about isosters. The atoms of different elements having same atomicity and number of electrons. Atoms of different elements have same atomicity and number of electrons. And same number of electrons called isosters. Not definitely the atoms, either it is molecules also having same atomicity. See, say not atoms, molecules. It will be good when we say molecules. When we take NO2 molecule, the atomicity is 3 actually. Number of electrons is nitrogen having 7 electrons and O2 molecule having 8 into 2, 16, and 16, 7, 23 electrons. So NO2 molecule having atomicity 3 and so when we take N2O molecule, atomicity will not change, but the electrons will change. Nitrogen having 7 into 4, 14, 14 into 14 plus 8, 22. When we take CO2 also molecule, the atomicity is not changed, 3, and electrons also 22 electrons. Carbon 6 and 16, 6, 22. Okay, this is about isosters. And another last one is isoelectronic species or isoelectrons. Okay, the species having same number of electrons are called isoelectronic species. Having same number of electrons, whether they are atoms. So atoms, we know that number of electrons are different with different atoms, but when we calculate according to their charge, they may be similar. When we take example, sodium plus, sodium plus means one electron loss, sodium plus means one electron loss. The actual electrons of sodium is 11, but losing one electron they get 10. When we take a similar Mg2 plus, actual electrons are 12, losing 2 electrons they get 10. So they are having same number of electrons. So they are isoelectronic species. Okay. These are about representing some basic concepts of representing elements, atoms, dividing into different groups. So let us discuss now nature of light. Okay. Okay, nature of light. This is one more important topic in this chapter. Nature of light. Now, there are two theories that are saying about nature of light. Actually, three theories. Third theory we will discuss later video. This video we will discuss corpuscular theory, which is said by Newton, and Huygens wave theory. Wave theory which is explained by Huygens. So these two topics we will cover in this video. Next there is electromagnetic theory, which is very important and which is true about light. These two theories are not completely 100% correct. Okay. First of all, discuss about corpuscular theory, which was explained by Newton. Okay, according to corpuscular theory, when we take source of light, the light propagates like small particles. So actually the light propagates like a wave, right? But according to corpuscular theory, light propagates through small particles. అంటే కార్పస్కులర్ థియరీ ప్రకారం న్యూటన్ ఒక సోర్స్ ఆఫ్ లైట్ తీసుకొని అతను ఏం గమనించాడంటే లైట్ అనేది స్మాలర్ పార్టికల్స్గా ట్రావెల్ అవుతుందని అతను చెప్పాడు. ఎవరు? న్యూటన్. ఓకే. ద ఫస్ట్ అబ్జర్వేషన్ ఈస్ light propagates like through like a small particles. These small particles called as corpuscles. Okay. These smaller particles called corpuscles, and these have no mass. So actually when particles means they are having mass, and particles అని అన్నప్పుడు దానికి మాస్ ఉంటుందని అర్థం. కానీ ఇక్కడ particles అని అనుకోకుండా న్యూటన్ కార్పసల్స్ అన్నారు. Newton said not particles. Newton said those particles as corpuscles. So they said he said that these have no mass. Okay. And he also said that different colors of light. So different colors of light is due to different sizes of particles. Different colors of light is due to different sizes of particles. He said that. And the third observation is these are rigid and elastic. These particles are very rigid and they are elastic. And he said that light propagates with more velocity in denser medium. Light propagates with more velocity in denser medium. And a denser medium, for example, take water. He said that while light propagates through air and water, comes to water, the light propagates through more velocity, the speed increases, he said. Now let us see drawbacks of corpuscular theory. Okay, these are the observations he said. Not exactly we say these are the postulates. There are so many drawbacks in his theory. The first drawback is he did not explain partial reflection and refraction. He does not explain partial reflection and refraction. So what is mean by this partial reflection and refraction? When we take this air medium and this is water medium, when we say that light comes through, light incidents at one point and reflects, actually it refracts. When it reflects, some particles, some light particles, they refracts also. So some light particles, they undergoes refraction because they are two different mediums, right? So some particles undergo refraction and some reflection. He did not explain why this is happening. So why this both reflection and refraction happening, he does not explain. And he does not explain diffraction and interference. He does not explain diffraction and interference. What is meant by this diffraction? When we take this is as a source of light, and when we take a small anything, small thing, and we make any hole, what happens? When we pass one ray of light particle, it passes through the hole, and what happens? It undergoes very straightly, but what happening? The light is expanding. When the light passes through a small hole, what happens? Then it will expand. It does not go in a straight line. It will expand. He does not explain why the light expands. That is diffraction. And what is interference? Also very easy. When we take one particle, when we take two things here and we make two holes, what happens? The light actually expands. The light expands, and here also the light will expand. So both light expands and they interfere in this part. Both light they expands and they interfere at that part. This is called interference. He does not explain both the processes. ఈ రెండు ప్రాసెసెస్ అతను ఎక్స్ప్లెయిన్ చేయలేదు, డైఫ్రాక్షన్ ఇంటర్ఫియరెన్స్ని. ఒక లైట్ పార్టికల్ మనం తీసుకొని ఒక ఆబ్జెక్ట్ గుండా పంపిస్తే అది ఎక్స్పాండ్ అవుతుంది ఇలాగా. అలాగే రెండు ఆబ్జెక్ట్స్ తీసుకొని ఒక హోల్ చేసి పంపిస్తే లైట్ అది ఎక్స్పాండ్ అయ్యి ఆ రెండు లైట్ పార్టికల్స్ ఎక్స్పాండ్ అయ్యి ఇంటర్ఫియర్ అవుతాయి. దాన్ని ఇంటర్ఫియరెన్స్ అంటారు. ఈ రెండు ప్రాసెస్ని అతను ఎక్స్ప్లెయిన్ చేయలేదు. ఓకే. అండ్ హీ సెడ్ వన్ రాంగ్ అబ్జర్వేషన్. He said the light propagates fastly in denser medium. Denser medium లో లైట్ చాలా ఫాస్ట్గా వెళ్తుందని చెప్పాడు, కానీ బట్ దట్ ఈస్ రాంగ్. While light propagates in denser medium, the velocity decreases because the refractive index increases. That we already know in the 10th class, right? That is one wrong observation. Okay, this is about corpuscular theory. Let us discuss about Huygens wave theory. And one more observation, he does not explain polarization also. Okay. What is mean polarization? When we take any source of light and when we take any crystal, మనం ఒక లైట్ పార్టికల్ని క్రిస్టల్ గుండా పంపిస్తే ఆ లైట్ పార్టికల్ అనేది స్ట్రైట్గా ట్రావెల్ కాదు, ఎక్స్పాండ్ కూడా కాదు, అది ఇలా ఉండిపోతుంది అంతే. ఆ లైట్ పార్టికల్ అనేది it stands like this. Okay, this is polarization. About these processes you will learn in physics, wave optics more deeply. Okay, it does not explain diffraction, interference, polarization, partial reflection and refraction also. Okay. Okay, Huygens wave theory. He said that light propagates in the form of wave. Light propagates in the form of wave. లైట్ అనేది వేవ్ రూపంలో, ఇన్ ద ఫార్మ్ ఆఫ్ వేవ్ రూపంలో ట్రావెల్ అవుతుందని హ్యూగన్ సెడ్ దట్. అగైన్ హీ సెడ్ దట్ డిఫరెంట్ కలర్స్ ఆఫ్ లైట్ ఈజ్ డ్యూ టు డిఫరెంట్ వేవ్ లెంత్. Different colors of light is due to different wavelength. This is correct actually. What said before, different sizes also is correct. We cannot say it is totally wrong, but actually different wavelengths of light is due to different wavelengths of particles. Particles on a wavelength పట్టి, ఆ సైజ్ ఆ వేవ్ లెంత్ పట్టి అది ఏ కలర్ కావాలో అది కంపారిజన్ చేసుకొని అప్పుడు వస్తుంది. సైజెస్ అలాగే వేవ్ లెంత్ రెండు కరెక్టే. ఓకే, అండ్ వాట్ ఆర్ ద డ్రాబ్యాక్స్? హీ కెనాట్ ఎక్స్ప్లెయిన్ ఫోటో ఎలక్ట్రిక్ ఎఫెక్ట్. About photoelectric effect we will learn in further videos. And he could not explain black body radiation. He could not explain photoelectric effect. He could not explain black body radiation. These are the drawbacks. Okay, I hope you enjoy the video, you understand the video. Okay, thank you for watching, and let us meet in next class. Thank you.